we're back. So excited to get the week started off in such a wonderful way. We are, as you guys know, getting into a brand new module right now. We are launching into a lesson, or module 4. It's a super long module, very, very different compared to module 3 because module 3 was a very short module. So we have 33 lessons in module 4. In module 4, we are going to be dividing fractions and multiplying fractions. So it's going to be Fraction City. Now that you guys are so wonderful at subtracting and adding fractions, we're going to be adding those other operations to our repertoire. And now we're going to be dividing and multiplying fractions, but we're not going to just launch into that right away. We're going to start off slow. Right now in lesson 1, we're going to be taking a look at some line plot graphs. We're going to be analyzing data, which you guys know I love, and we're just going to be kind of checking out some line plot graphs. And then tomorrow in class, we're going to do an activity where you guys will actually generate your own line plot graph by gathering some data from kids in our classroom. So let's take a look at these line plot graphs. Here we go. Here we go, guys. We are in module M4L1. We're going to look at one problem today. As you can see, it's kind of long, so it's kind of a one problem, but it has multi-steps. So line plot graph is this line right here. We are going to be plotting data. Data is all of these rainfall amounts. It's just a bunch of data that has been gathered for this problem. This is probably made up. Just know that this probably was not gathered in the actual field. Let's figure out what's going on here. So we have the story. A meteorologist set up rain gauges at various locations around a city and recorded the rainfall amounts in the table below. I actually moved the table over here, so the table to the right. Use the data in the table to create a line plot using 1/8 inches. Okay, so we have all these different locations. So the first column is just the numbered locations, 1 through 10. The second column, as you guys can see, is the rainfall amount in inches. So we have 1/8, 3/8, 3/4. So we have all these different rainfall amounts. This is our line plot graph. And you know, I'm actually going to make this longer because I'm going to have a very difficult time squeezing that all in that space, knowing how large I usually write. So I'm going to actually extend this line plot graph. What we need to do is we need to label the line plot graph. We're going to start at 0. Wow, shocker. I'm going to look through our rainfall amounts and I'm going to say, what is our largest number? And whatever our largest number is, that's what number we're going to label to the far right. So I have like kind of small numbers. Oh, that looks large. It's a mixed number. Okay, cool. So it looks like our largest number, you guys, is going to be 1 1/4. And you can label your line plot graph in a lot of different ways. I'm going to go ahead, actually, this is bossy, so we have to label it in eighth of inches. So I'm going to just go ahead and make our largest number here on the far right 2. So we have 0, we have 2. The number that occurs halfway between 0 and 2 is 1. And now what we need to do is divide the space between the whole numbers into eighths because that's what we're told to do. So we've got 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, cool. And then I'm going to divide the space between 1 and 2 into eighths because that's what we're asked to do. 1, 2, 3, 4, 5, 6, 7, 8. Okay, very cool. So now what we're going to do, you guys, is we're actually going to plot this data. The data, again, are all of these measurements. I'm telling you, hold on, I'm being interrupted by someone that forgot their lunch. Now we're going to start plotting our data. And we're actually just going to, so my first measurement is 1/8. I'm just going to, actually I'll change this, just make an X on top of 1/8 to signify that there was one location that measured 1/8 of an inch for rainfall. Okay, then I'm just going to kind of like cross these off as I do them because sometimes it's difficult to keep track. Okay, so now our next Our next rainfall amount that was measured is 3/8. So now I'm going to look at, so I have 1, 2, 3. I'm going to put an X above 3/8 because that was the measurement for the second location. Now let's look at the third location. Third location is 3/4. Oh gosh, well my space in between my whole numbers is eighths. Well, this is what we're going to have to do. We're going to have to figure out what amount of eighths is equal to 3/4. We need to find the equivalent fraction. So what can I multiply 4 by to transform it into an 8? Well, I can multiply 4 by 2 to make it an 8, which means if I want an equivalent fraction, I have to, oh goodness sakes, Mrs. Calamir's, multiply 3 by 2. What is 3 times 2? 6. Great. So 3/4, my friends, is equal to 6/8. I'm going to go ahead and plot 6/8 on my line plot graph here. Let's look at 1/8, 2, 3, 4, 5, 6/8 is right here. Beautiful. So we have our first 3 locations plotted. Let's look at our fourth location. 3/4, I know 3/4 is 6/8. So now we have 2 locations with the same measurement, which means we're just going to stack the x's one on top of another. The x's again represent the locations, and this location is at, I'm just going to mark this, is at 6/8. Okay, so now I can see I have 2 locations that measured 6/8 of an inch for rainfall. Okay, we have our fourth location. Now let's look at our fifth location, 1/4. Okay, well, I need to figure out what is my equivalent fraction that has a denominator of 8 because my space between my whole numbers is divided into eighths. I need to transform 1/4 to some amount of eighths. Well, I can do that very easily because I know 4 times 2 is 8. I also need to multiply the upstairs by 2. 1 times 2 is 2. Cool. 1/4 is equal to 2/8. So let's go ahead and plot that on our line graph. Again, all of these lines are eighths. So 1, that's 2/8 that I just marked. Great, we have location 5 labeled. Let's look at location 6. Location 6 has a denominator of 1. I'm so sorry. Location 6 has a denominator of 4. It's 1 and 1/4. What is 1/4 equal to? Well, I actually just figured out that 1/4 is equal to 2/8. That's equivalent fraction. So 1 and 1/4 is also equal to 1 and 2/8. So I can go ahead and plot that location 6 rainfall amount on my graph here. So here's 1 whole. 1 2/8 is right here, and I'm going to show that with an X. Beautiful. I have location 6 labeled. You guys, please know that I know this is new and this is kind of goofy. We have a problem just like this on our mid-module for celebration of learning. So we're going to practice plotting this data and analyzing it. It's a really important skill in math and science in 5th grade and will be for the rest of your educational career. The analysis of data and plotting data is so important. What we're doing, you guys, we're taking this list of numbers and we're actually arranging it in a very visual way so that we can analyze the data. The data, of course, we're transforming into x's. So let's look at our next data point, which is 1/8. 1/8 is right here. This is my second location that has rainfall amount of 1/8. So I have 2 x's stacked on that data point. So that one's done. 1/4 is equal to, we've already found this up here, 2/8. So we're going to plot location 8 as 1 2/8. Again, this is our second 2/8. So we have 2 x's stacked on top of 2/8. That's where we are. Beautiful. So we have location 8 handled. Location 9 is 1 whole. Well, I can handle that. Let's put an X on 1 whole. Beautiful. That is handled. And then location 10 is 1/8. This is our third measurement at 1/8, so you guys can see that we have 3 x's there. Beautiful. So we have all of our data plotted on our graph here. Now let's go ahead and look at these analysis questions. Which location received the most rainfall? Well, that's interesting. The most rainfall, if I look on our graph here, 0 is all the way to the left, 2's all the way to the right. What do we have right here? We have 1 whole, we have 1 and 1/8, and we have 1 and 2/8. So this, I'm going to change colors. That location at 1 and 2/8 measured the most rainfall. Which location received the most rainfall? Well, that's the location at 1 and 2/8. Which number location is at 1 and 2/8? That's location number 6. So location number 6 had the most rainfall. The most rainfall recorded on this data table is 1 and 2/8 inches. Beautiful. Which location received the least rainfall? Okay, so the most rainfall happened at the X that's farthest to the right. The least rainfall is going to show up farthest to the left. And it looks like the least rainfall is actually a tie here. We have 3 different locations that measured 1/8 of an inch. 1/8 of an inch is our lowest rainfall recorded, and that actually occurred at 3 different locations. So, which locations received the least rainfall? That would be location number 1 had 1/8. That would be location number 7 also had 1/8. And also location number 10 had 1/8. It's a triple tie for the least rainfall collected or measured. Very good. Let's look at see which rainfall measurement was the most frequent, meaning of all of these X's, of all of this data that we plotted, which measurement recorded has the most X's stacked one on top of another? We can see, wow, again, 1/8 has, you guys can see 3 X's stacked on top of there. So which rainfall measurement was the most frequent? Well, 1/8 of an inch was recorded at 1, 2, 3 different locations. So the rainfall that was the most frequent was 1/8 of an inch. That little quotation mark is the shorthand for inch. What is the total rainfall in inches? Oh, this is an interesting one. Let's see if we can challenge ourselves and do this in our head. So all of these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 X's represent these 10 locations and their rainfall amount collected. We have this organized so beautifully. Let's go ahead and do our best to calculate this mentally. All of the good news is that all of our denominators are 8s. So I think we could probably handle this mentally. So here we have 1, 2, 3/8. Okay, so I have 3/8 there. And then here we have 3/8 plus 1, 2 sets of 2/8. 2 sets of 2/8. 2 copies of 2/8, you guys? Well, that's 4/8. Okay, beautiful. So we have 3/8 plus 4/8. That's equal to 7/8. Okay, so that's what we have so far. These 1, 2, 3, 4, 5 locations measured 7/8 inches of rainfall. Okay, now we have to look at 7/8 plus, we have 1x, 1 location on 3/8. 7/8 plus 3/8 is equal to 10/8. I'm just going to go ahead and document that so we don't forget. Okay, so we have these handled. Now we have 10/8 plus 2 copies of 6/8. Well, 2 copies of 6/8 is what we're looking at for this, excuse me, for this location. Let's figure out what that means. 2 copies of 6/8 is 2 times 6/8, or 6/8 plus 6/8. Well, 6 plus 6 is 12. So 2 copies of 6/8 is 12/8. Beautiful. So here we're looking at 10/8 plus 12/8, which is 10 plus 12 is 22/8. You guys don't worry about simplifying until we get to the end of this. Okay, so that's 22/8 through here. Now we have 22/8 plus 1. Okay, well, 22/8 plus 1 is equal to, let's slide over here, 1 and 22/8. Again, I realize that this is not simplified. We'll worry about that when we're finished. Okay, so that's all of the rainfall through here. Now, our last data point is at 1 and 2/8. Can we add those two numbers together? Absolutely. Well, 1 plus 1 is 2. 22/8 plus 2/8 is 24/8. So we have 2 and 24/8. This is our secret word, you guys. This is an improper mixed number. I need you to simplify this as your secret word. 2 and 24/8 are all of these data points added together, but 24 is much larger than 8. So I need you to simplify this number and tell me the final version of our rainfall. You're going to do that by thinking about, how many whole numbers can I pull out of 24? And I shouldn't say whole numbers. Let's just think about this quickly. 8/8 is equal to 1. So how many whole ones can you pull out of 24/8? Okay, so simplify this number. That is your secret word. Check it in tomorrow morning. And I will see you guys in the morning.